Yes, hello my dear students, welcome back to the St. Joseph Composite PU College, Vijaypur. I'm Rahul and in this video I am extending the topic called solution, and now I am going to discuss here solubility of gas in liquid. Okay, this is wondering that most of the gas molecules are easily soluble in a liquid. Okay, and the solubility depends upon various factors. So factors that affect the solubility. We can list the factors affecting the factors affecting solubility solubility of gas in liquid. That the first factor is that nature of that's a gas, nature of gas, and the solvent the which type of gas and which type of solvent you are using, that really affects. The second one is temperature, and third the factor is the pressure. There are total overall we can say that these are the 3 points are there. On that we can say that obviously the solubility of gas is dependent. Okay, let's understand this with in detail. The first one, the nature of the gas. Okay, nature of gas. Okay, this is the first factor. Let me write here nature of gas. Okay, nature of gas. And there are two type of gases I can list, like hydrogen gas, nitrogen gas, or helium gas, right? Or even you can take nitrogen, you are taken oxygen gas, you can take oxygen gas, and even you can take argon. Like these are the some gases when you try to dissolve in water, they form insolubility. They never get soluble. They are insoluble. If they are soluble, they are soluble in a very small extent. Insoluble, but in a small portion they can be soluble. Okay, in small extent soluble. Why they are soluble only in small extent? Because there is no interaction between the solute and solvent. There is always less interaction between the solute and solvent, because all these molecules are non-polar molecules. These are non-polar molecules. Even these molecules do not form any kind of interaction with the solvent. Next, there is another type of solutes are there, like or you can say that gas molecules are there, like carbon dioxide gas, or you can take here the gas like SO2. Okay, and even we can take here the HCl gas. Okay, and we can take ammonia, that is NH3. Such molecules easily soluble in water. So we can say that water, they form soluble solution, or we can say that form a solution, they get soluble. And here the extent of solubility is very high. A large extent soluble. Okay, large extent is soluble here. The reason is very simple, students. Here when you look at these molecules have capacity to form interaction with the solvent molecules. Like when carbon dioxide gas is interacting with water, it form a chemical reaction. So it forming here chemical reaction. Let me write here these two right here. These two interact and form a chemical interaction takes place. Chemical interaction is taking place, and after that what we get here? We get here H2CO3. We get carbonic acid. Carbonic acid we get, right? In the same way, when ammonia, that is NH3, when NH3 is reacting with the molecule of water, let me take here water, and there is also chemical interaction taking place, and we form here NH4OH we get. The ammonium hydroxide we get. Okay, ammonium hydroxide. Okay, these are the, you can say that the interactions. Even let me write here the SO2. When SO2 gas molecule is interacting with the water, it forming here, you can say that there is H2SO3 is formed. That is sulfonic acid. Yes, sulfurous acid. Okay, sorry, this is sulfurous acid is formed. And similarly, the HCl is also forming here hydrochloric acid when it interacts with the water. And this is how we can say that there are two type of molecules are there. The one which are not interacting with the water molecules or the solvent, and they are soluble only in a small extent. Why they are soluble in only a small extent? Because they are non-polar molecules. They don't have any interaction with the water. They don't have any interactions. In the other hand, the molecules like carbon dioxide, sulfur dioxide, HCl, and ammonia, these molecules form chemical interaction with the solvent like water, and they form some stable chemical compounds here, and because of that reason they are more soluble. Okay, that's the one part. Let's understand that how the temperature affects the solubility. Okay, let me have this here. Okay, that is temperature. The second point we're going to discuss, that is temperature. Temperature. Okay, very interesting fact is that when I take a container, let me take some container over here. There is some container is there, and in that container I will take some water here. I will take some water here. Okay, this is a water. Okay, let me write here H2O. Now what I'll do that in this, I'm going to dissolve some gas molecules. Okay, assume that some gas molecules. So let me take some other colors. The yellow gas molecules are there. Gas molecules above the surface. And when the gas molecules are present at the above the surface, obviously they get dissolved in a water or in a solvent, in any of the solvent. Okay, so now obviously what happens here, when the gas molecules are dissolving in a water, you can say that they come close to each other, means in their thermal energy is decreased, and decreased thermal energy came out in the form of heat. Therefore the dissolution of gas, that is, let me write dissolution of gas plus water, or let me write, I don't want to hear in plus water, in water I will write in water is exothermic process, is exothermic process. Okay, this is what we have. This is when the gas molecules are dissolved in a water, the temperature of the water is rise. The rising temperature is due to the reason that when the gas molecules get dissolved, the gas molecules come close to each other. When they come close to each other, means their thermal energy is losing there. That lost thermal energy is appeared as a temperature rise in the water, right? There is a rise in the temperature in the water, right? Now what happens if I increase the temperature? So when I heat this, so heating leads to the gaining of kinetic energy of the gas molecules. When temperature is raised, temperature is increased, something happened with the gas molecules. That is, the gas molecules, or you can say that gas particles are, let me write here the word particles gain kinetic energy, and due to that they move randomly in all directions, and due to this kinetic energy they overcome the force of attraction, overcome force of attraction, attraction. So this force of attraction between the gas particles, and you can say that gas particles or gas molecules and the solvent, you can say overcome the force of attraction between solute and solvent. Okay, and now the gas try to escape from the solvent. Now the gas escapes the you can say that escape the solvent. Okay, as a result what happens, the concentration that leads to decrease in the concentration, decrease in concentration of you can say that solute, that the gas is here solute, the decrease in the concentration of solute takes place. Okay, these all things are taking place here. As you increase the temperature, the gas molecules gain the kinetic energy. That is the most important thing. When they gain a kinetic energy, they move randomly in all the directions, and because of that what happens here, they overcome the force of attraction between the solute and solvent, and by that the gas molecules try to escape from the solvent, and that leads to the decrease in the concentration of the solution. And we can make a statement here, by increasing the temperature, the solubility of gas decreases. Okay, by increasing temperature, temperature, the solubility, by decrease, you can say that increasing the temperature, solubility of gas decreases. Solubility of gas decreases. Okay, this is, we can make a statement from this observation. But at what temperature the solubility of given gas is maximum? At cold, or you can say at low temperature, the solubility will be more. This is the inverse of this statement, right? By decreasing the temperature, the solubility of gas is increased. Like that, we can write in inverse of this given statement. Therefore, you can see that the aquatic animals are exist. You can say that they exist at the lower temperatures. Why? Because at lower temperature, the oxygen is dissolved more, right? So therefore, the aquatic animals can survive more at the 4 degrees Celsius, but that's the lowest temperature, where you can say that our cold temperature, because there the availability of oxygen is more as compared to the hot water. Okay, that is one part. Now next, there is one last factor, is that's the effect of pressure. Effect of pressure. Effect of pressure. This is the last factor we're going to discuss in this video. The effect of pressure is very important. On that we can going to study the Henry's law in the next video. But thing is that here the solubility of gas, solubility, I directly will write solubility of gas is directly proportional to the pressure. So as you increase the pressure, the gas molecules come close to each other, and because of that reasons, what happens, the gas molecules can liquefy there and get dissolved in a solvent. Only thing is that when you increase the pressure, the solubility of gas is also increased. And the application of this factor we're going to discuss in the Henry's law. Let's see in this that in the next video. Thank you for watching this, students.